Hello, my name is Devan Liu, and this is Project 1.3 Accounting Circuit. Today, I will explain the 8 parts that are required to make accounting circuit and what it is. This is the NAND gate oscillator button input. When the button is at rest, the LED will turn on. The button input uses a pull-up resistor configuration because when the button is pressed, the pull-up resistor will use all the voltage, making pins 12 and 13 receive a low. This will make the LED turn off, since for the LED, there is no direct path to ground. If a pull-down resistor was used, then pins 12 and 13 will always be high since the current passes through the pins before the resistor. This is an example of the button input. When the button is pressed, the LED turns off, and when the button is released, the LED turns back on. This will power the NAND gate oscillator. This is the NAND gate oscillator. There are two resistor and capacitor circuits in here. There's RC1 and RC2. RC1 will control how long the oscillation will last, while RC2 will control how fast the oscillation speed is. But what is an oscillation? The NAND gate oscillator creates an oscillation between a high and a low state. This creates a clock signal. One period or one clock means when one cycle has happened. As said before, RC2 controls the oscillation speed of the clock signal. The higher the capacitance and resistance there is, the slower the clock will oscillate. RC1 controls on how long the clock will keep on going. The more capacitance and resistor there is, the longer the clock signal will go. The clock will keep on going until the capacitor empties. Up next is the decade counter 4017 chip. The purpose of the 4017 chip is to organize the highs from the clock signal and give us a visual representation of how many highs have happened. The 4017 chip counts to 9 with the carryout. Pin 14 is where the clock signal goes in, and pins 16 and 8 is what you use to power the chip. When high, pin 13 will freeze the counting, and when pin 15 is high, it will restart the counting at 0. Pin 12 is the carryout pin. Pin 12 divides the clock signal by 10. This could be added to another 4017 chip through pin 14 clock input to count the tens place. To divide by 10, pin 12 is high for counts 0 to 4 and low for 5 to 9. Up next is the 4510 binary up-down counter. The purpose of the 4510 chip in the counting circuit is to convert the divide by 10 output from the 4017 chip into binary and slow down the counting from the original clock signal. Binary is the language of computers and only has two states, low and high, or 0 and 1. Each place is 2 times greater than the next. Once the digit is 1, it goes back to 0 and the 1 gets carried over to the next place. The 4510 only has 4 output lights, meaning that it can only count up to 30 in binary. Up next is the 4511 binary counting decimal decoder. This chip decodes the output from the 4510 chip and converts it into something readable for the 7-segment display. To connect the 4511 chip to the 7-segment display, connect each pin to the corresponding lead on the 7-segment display LED. For example, pin 13 would connect to pin 7 on the 7-segment display. It is helpful to have a pinout diagram and the 7-segment display pinout diagram. When connecting the 4511 chip to the 7-segment display, make sure that you have resistors in between them to avoid burning out or blowing the LED segment. The counting circuit PCB is the version 3 and provides a more stable and more permanent connection. This also gives it a very clean and organized look. When soldering, make sure that you don't leave the soldering tip onto the solder for too long or else you might burn the solder. The 3D printed case holds the PCB, and inside there is a battery compartment. When inserting the battery, make sure you wrap it in electrical tape to prevent a short circuiting throughout the circuit. In the end, you'll be given this sleek and polished design. In conclusion, the NAND gate oscillator helps students understand what a counting circuit is and what it's counting. It provides information to students on what a clock signal is and what a NAND gate oscillator is. Thanks for watching my video.